I had number 7, and it states, a rhombus of side length s has the property that there is a point on its longer diagonal such that the distances from the point to the vertices are 4, 4, 2, and s. And it's asking what is the value of s. So I started by drawing a rhombus with side length s, and then I can draw in the longer diagonal and the shorter diagonal. Now it's a property of rhombus diagonals that where they intersect is actually, it splits the diagonals in half, so they bisect each other. So we know that this is congruent to this. And they also form 90-degree angles. And the problem states that there is a point on the longer diagonal that the distances to the vertices are 2, 4, 4, and s. Now we know that these two are both 4 because from this point to 2 congruent vertices would be the same. So we need those to be the same, so we know that those are 4. And this point to the vertice that's closer is going to be the shorter distance, which is 2. And that leaves s to be that side. So from here, I took 2 triangles to be able to set up a systems of equation. So I have 2 triangles, and they are going to represent this larger triangle as the outside one. So we know that the hypotenuse right here is of length s, and we know that this portion is 2, and the entire portion is s plus 2 divided by 2, because we know that this part is s and this part is 2, so the total is s plus 2, and we need exactly half of it because these portions are bisected by the other diagonal, so they are congruent. So we need s plus 2 divided by 2 to be the entire length. And when you work this out, you get s over 2 plus 1. But we need to subtract the 2 to get this portion right here. So we do that, and we get s over 2 minus 1. So we know that this part of the triangle is s over 2 minus 1 because it's the total length minus the 2. And I decided to call this side length x. So now we have 2 different triangles that we can set up a Pythagorean theorem from. So for the outer triangle, the big triangle, we know that s squared, because that's the hypotenuse, is equal to x squared plus s plus 2 over 2 squared, because that is the long length of the base. And therefore we know that s squared is equal to x squared plus s squared plus 4s plus 4 over over 4, because the 2 gets squared, and then it's s squared is equal to x squared plus s squared over 4 plus s, because the 4's cancel, and plus 1 because the 4's also cancel there. And I'm going to solve for x squared because I want to, in the end, cancel out x, so I no longer have x's and I'm only working in s, which is what I need to solve for. So I get x squared is equal to, and I move these 3 components to the other side of the equation, and s squared is equal to 4s squared over 4, so I know that that leaves me with 3s squared over 4 minus s minus 1. And now I'm going to work with the second equation. So now we're going to work with the smaller of the 2 triangles. So we know that this distance is actually 4 because they told us that from this point to the vertice is 4. So I know that 4 squared is equal to x squared plus s over 2 minus 1, because that is the distance of the base. And that is also squared. So we know that 16 is equal to x squared plus s squared over 4 minus s plus 1 when you square this. And now we actually know what x squared is equal to, so we are just going to sub it in to be able to work in only terms of s. So we know that 16 is equal to, and we're going to replace x squared with 3s squared over 4 minus s minus 1. And then we still have to add the later portion of the equation. So we get s squared over 4 minus s plus 1. And the minus 1 and the plus 1 cancel here. So we get 16 is equal to 3s squared over 4 plus 1s squared over 4 is just going to leave us with s squared, and then minus 2s. So from there we can move it to all on one side of the equation, and we get that s squared minus 2s minus 16 is equal to 0. So now all you have to do is factor this equation, but we're going to have to use the quadratic equation because it's not easily factorable. So from this equation, you get that s is equal to 2 plus or minus radical 4 plus 64 all over 2. And you get that s is equal to 2 plus or minus radical 68 over 2. And radical 68 can be divided by 4, so you know that it's 4 times 17 is the same thing as radical 68, so you can pull out a 2 and leave it as 2 radical 17. Now, we only want the positive portion of this because if you use the negative, the 2 minus radical 68, you'll get a negative number, and the side length of a rhombus cannot be negative, so we only want 2 plus radical 68 over 2. So therefore we get s is equal to 2 plus 2 radical 17 over 2, and we can cancel out 2's, so we get s is equal to 1 plus radical 17. And this is your answer. So all we did was set up a systems of equations based on Pythag from the distances that were given. And we get that s is equal to 1 plus radical 17.